Okay, this is sample problem 4.2, which is on page 110. So in my book, I'm going to write 4.2, page 110, doing that in my notes. And I'm going to read the problem. And again, the sample problem all by itself looks like a lot of stuff and kind of confusing, numbers and letters and things. So you cover it up. And here's the question, just like the homework question. A student weighs 588 newtons. What is her mass? Well, gosh, they hardly give you any information at all. So now you got to start thinking. Let me see. Do I remember the formula? I just covered the formula earlier on weight. Weight is equal to m times. Oh, wait a minute. G, and G is something I'm supposed to know. All right, I think now I got some clues. So let me see what it says I should be thinking. Newton's second law allows us to determine the object's mass if we know the object's weight, since G is known. So again, it's telling me I'm supposed to know G, which I do know G, so I can do that problem. So let me see if I can think it through myself. Okay, if I know weight, I list my weight as 588 newtons, and I know G is 9.8 meters per second squared. And what am I looking for? What is the mass? So mass is m. So here's how I want to start it. Well, let me see what it tells me to do. Solution. It lists your givens and find your mass. And then, so it's only giving you the weight, but you have to recall that weight is part of acceleration due to gravity. And it goes back and it reviews that formula with you right in the sample problem. It tells you weight equals mg and tells you where to find it, equation 4.2. And if you were so inclined, for instance, if this wasn't as easy as this one, you would have to page back in your book a couple pages until you found 4.2, which is, let me move the book a little bit. There's 4.2 right here. And there's a formula, W equals mg, which I already wrote in my notes because I read this chapter. I've read so far into this chapter. So okay, there it is. I went back and I found the formula, and they were right. It was there, and I remembered it, so I wrote it down here. Acceleration due to gravity, and they give you the value 9.8. And rearrange the equation for weight, W equals m times g. So I want to get m by itself, divide both sides by g. So m must equal w divided by g. And when I uncover it, sure enough, there it is. M must equal w divided by g. It tells me to rearrange the equation. I tried it on my own, and then they showed me what it should look like. So if I made a mistake, I could look at it and go, oh yeah, all right, well, and then I would go back and I would cover it up and I would try it again. But I didn't make a mistake, and then I plug in my numbers. And it shows the numbers plugged in, but I'm going to go ahead and plug them in myself anyway, because that's what using the sample problem is about. M equals W over G, 588 newtons, divided by 9.8 meters per second squared. Now remember, let me do it like this, 588, a newton is really a kilogram meter per second squared. When I divide that by 9.8 meters per second squared, meters per second cancel out, I'm left with kilograms, and so I come up with some math. And so if I divide 588 divided by 9.8, I get about 60 kilograms. And so I go back and I look at the problem and I read it, and sure enough, 60 kilograms. It works. And on the surface of the earth, this is equivalent to 60 kilograms. And there's a conversion factor. This is from chapter 1, how to convert from kilograms to pounds. It tells me there's about 2.2 pounds per kilogram. So about 2.2 pounds per kilogram. And then I want to multiply that by 60 kilograms. And I know it's worked out, but the idea about using this as a tutor is I practice these skills. So 60 kilograms times 2.2 pounds, lb per kilogram. Kilograms cancel out, 60 times 2.2, and I come up with, I don't know, about 132 or something like that, 132 pounds. So now I've got a way of converting pounds to kilograms. And let's see, they work it out for me, and there it's all worked out right there. And so a lot of systems that use the metric system, kilograms. um, units of mass rather than force units is used to express weight. Should we say the student's weight is 60 kilos? And so they're talking about the mass, but everybody knows that they're talking about their weight, because on the Earth, your mass times 9.8. It's going to be 9.8 for everybody on the planet. So in some places, they just ignore the 9.8. They just talk about the 60 kilos as though that's your weight. And if you want to lose a little weight, you got to lose a couple of kilos. And here's the follow-up. So they tell you if you want to lose 5 kilos, what would be the equivalent loss in pounds? Well, we'll go back and do it. If I want to lose 5 kilos, and look at it, it's just like the sample problem I just did. I multiply that by 2.2 pounds per kilogram, and I come up with about 11 pounds. And so it's a sample problem, and it tells me that the answers to all the follow-up exercises are in the back of the text. So if I want to go check that, I could go to the back. But you know what? It was exactly like the problem I just did. It was exactly like this problem. So I really don't think like I've got to go look it up. I think I've got the right answer. So I've done this one right.